How do we evaluate a zero exponent? And then also a second property we're going to look at is power to a power. All right, so definition, zero property of exponent. So any number raised to the zero power is equal to 1. Wait, what? So you're telling me that 5 to the zero power is equal to 1? Okay, let's figure this out. Here's two examples. If I have 2 to the x power, I'm going to fill in my table here. This is 2 to the 0, 2 to the 1. The x value we're substituting in for into the function. So 2 to the 2, 2 to the 3. Okay, so we'll start with 2 to the 1 is 2, 2 to the 2 is 2 times 2, which is 4. And then this is 2 times 2 times 2, which is 8. So I can see I have 2, 4, 8. It looks like every time I'm multiplying by 2. So if I take my output and I divide it by 2, so 2 divided by 2, what does that give me? 1. Does that fit with the pattern? Okay. 1 times 2 is 2. Yeah, 2 times 2 is 4. 4 times 2 is 8. So remember, math is just patterns, so we need to make sure that the numbers that we plug into our pattern makes sense. Okay? All right, here's another way to think about it. I know from yesterday that my exponent rule, what is 8 to the second power divided by 8 to the second power? Remember, anything divided by itself gives me 1. But 8 to the second power over 8 to the second power, how can I simplify that? Remember yesterday, this is 8 to the second minus the 2 from the bottom, giving me 8 to the 2 minus 2, which is 0, still means it's equal to 1. Booyah! Okay, so anything to the 0 power is equal to 1. Here's our rule. Anything to the 0 power, so any base, a to the 0 power is equal to 1. So if I have g to the 0, that's equal to 1. If I have 5x all raised to the 0, that's equal to 1. Okay? All right, don't forget your definition. They're going to be at the bottom of the page today. All right, so simplify each expression with only positive exponents. So 2 numbers on the inside. So this, I can rewrite this as x to the 0, y to the 0. What's anything to the 0 power? I get 1 times 1, which is 1. That's it. Or this whole base inside the parentheses raised to the 0 power is just going to give me 1. Okay. All right, the next one. You're trying this one. This one's trickier. Check it out. Any number with the base of 2 has an exponent of 3. The base of x has an exponent of 0. So I have to evaluate them separately. 2 to the 3 is equal to 2 times 2 times 2, which is 8. And then x to the 0 is equal to 1. So this is going to equal 8 times 1 is 8. That's it. Next up, negative 5 times y to the 0 plus 5. So 5 has an exponent of 1. Y has an exponent of 0. So I get negative 5, and then y to the 0 is 1 plus 5. So negative 5 times 1 is negative 5 plus 5. Simplify to give me 0. All right. Negative 3x plus 7, all raised to the 0 power. So everything inside the parentheses here is being raised to the 0 power. Now, it's not like the first example where I was able to split these up into x to the 0, y to the 0, because I have an addition inside the parentheses. So we will have to just say that all of this business inside the parentheses raised to the 0 power is equal to 1. All right, up next, power to a power property. So if you're raising a power to a power, then we are multiplying the exponents. Here's the rule. A base, a to the m, raised to the n power. Notice there's no a right here for n. The base is a to the m. So what you do is you multiply the exponents, okay? So here's an example. X to the third raised to the fourth power. I have 4 copies of what's in the inside of the parentheses. So I have x to the third times x to the third times x to the third times x to the third. Now each of these exponents has its own base, of x. How many x's do I have in total? See, I have 3 here. So x times x times x times x times x times x, another 3, and then another 3. So in total, I'm going to add all these together to give me x to the 12. Now the quick, fast way to do this is to go like this. There is no second base here. So I'm going to multiply 3 times 4. So this gives me x to the 12th. Matchy, matchy? Matchy, matchy. This is the shortcut way. Okay? All right. So the rule for division is just that the exponent goes to both, the outside exponent goes to both exponents on the inside. Okay? So we're going to start with our examples. So negative 3 times v to the second raised to the fourth. What is the exponent on negative 3? The exponent on negative 3 is 1. The 4 is only being applied to this v to the second. So since the 4 doesn't have another base, I'm going to go ahead and just multiply the 2 and the 4 together, giving me negative 3 times v to the 2 times 4. So that's negative 3 v to the 8th. Okay, what's the exponent on negative 3 again? Oh yeah, 1. Okay, you try. So g to the 3 raised to the 7th. Do I add or do I multiply the exponents? I multiply them because the 7 doesn't have its own base. If this was like this, g to the 3 times g to the 7, then I would add the exponents. But that's not what we have. So we're going to go ahead and multiply. G to the 3 times 7 gives me g to the 21. Another example. The quantity 7v to the 3, all raised to the second. So this time, is the 7 in the inside or the outside? Is it being affected by the squared or not? Since it's inside the parentheses, it is being affected by the squared. So what is the exponent on the 7? It's a 1. Oh, the 3 only belongs to the v. Okay, so we're going to go ahead and distribute this exponent into both of these into both of the bases. So I get 7 times 1 times 2, okay, the original exponent times the outside exponent, times v to the 1 times, not 3, sorry, and not a 1. So v to the 3, the inside exponent, times the outside exponent. So I get 7 to the 2 times v to the 6. What's 7 to the 7 squared? That's 49v to the 6. All right, last one on your own, and then we'll go over it. All right, so negative 11 is, the exponent is a 1. Okay, so I'm going to go ahead and write negative 11 times 1 times 2 for the outside, and then the exponent on the x is also a 1. So I'm going to do x to the 1 times 2, and then the y has an exponent of 3. So y to the third times 2. There are 3 different bases available. Okay? So next thing I'm going to do is go ahead and evaluate. So I get negative 11, 1 times 2 is 2, and then x to the 1 times 2 is 2, and then y to the 2 times 3 is 6, and then any number just plain number base, we can evaluate. So negative 11 squared is negative 11 times negative 11, which gives me positive 121. Bring down the x squared and the y to the 6. And that's what we simplify to. All right, don't forget your summary and your vocab.